Now let's see how does LDA works. Although R will do this for us, but we should understand this to know the concept. Suppose we have our data as shown here. So we will use a decision boundary to discriminate between the two classes. But the question is, how do we get to this decision boundary? So we project the data onto a new plane such that we maximize the distance between means of two classes and minimize the variation within each class. So what does this mean? Now as you can see, we have projected the data onto a new plane called LD1. This will always be 1 less than the number of classes. We get this LD1 using the coefficient of discriminant. We will see this in detail in the assignment part. Okay, so now if you look at the data and the axis here, we can see that the mean is maximized between the two classes and also the variance is minimized within each class. So we will choose that decision boundary which will help us achieve this. So that was just to explain how things work in the background. Mathematically, in LDA, we compute discriminant scores for each observation to classify which class the response variable belongs to. Suppose we are working on loan defaulters and want to classify individual to defaulter or not defaulter categories. So our goal is to maximize the linear discriminant score, which can be calculated using the formula shown here. The entire function is called as linear score function. Delta x is the estimated discriminant score. Mu is the average of all the training observations from the kth class. Sigma is a covariance matrix that is common for all classes. Pi k is the prior probability that an observation belongs to the kth class. Now as this formula looks a bit scary, so obviously we are not going to remember it. We will let R do the calculations. Now once the score is calculated, classifier assigns an observation to the kth class for which discriminant score is largest. So that is how linear discriminant analysis works. Now second we have quadratic discriminant analysis. So we saw earlier that in QDA, variance covariance matrix is not constant. QDA assumes that each class has its own covariance matrix. In other words, the predictor variables are not assumed to have common variance across each of the k levels in the response y. The formula for calculating the discriminant score is modified as below. Here summation k is the covariance matrix for kth class. That is the only change in QDA. Earlier we had this covariance matrix common for all the k classes. Now we have individual covariance matrix for all the classes. So that is how we calculate discriminant score in QDA, and then rest of the process remains the same.